Solve the problem. Take a breath.
That one right there, right?
Yeah, this one right here. This one right here. This one right here. I have a 6, I have a 7, I have a -1, and I have a 26, and I'm putting a 3 in the box. You guys see where the 6 and the 7 and the -1 and the 26 came from?
This did you see Mr. Huff get hugged?
He literally
He went for a handshake and then he
That
just
guy was
got
a
like,
maniac. I'm not gonna lie. He's definitely correct or something. He's pretty much me as a pastor.
Misty, did you understand the message at all?
Well, he's the rough part.
If love does, then he does love.
Waiting
Like,
on
it was like,
on hold with Kaiser. So I'm just.
yeah, it was, you didn't miss much.
You know, chocolate.
Yeah.
Emily.
Yeah.
Alec. Here we go. Synthetic division. We have all this stuff over here. We have this guy, let's see, factor. And we have his 0. You can actually call it solution if you want.
Excuse me.
I put it on.
0, solution, etc., factor. Factor is the linear pair. Factor is like the x minus a or x plus a. The solution is what the 0 would be. So if you guys notice over there, x minus 3 is my factor. But who's going in the box is my solution. Pretty much, the steps are pretty much just working out or talking out what I did in the sense of I took the polynomial's coefficients that I'm trying to divide. I plugged the solution into the box. I'm going to carry down the first coefficient, which is the 6. And then what? What's the pattern? Multiply. So 3 times 6, take the box. 3 times 6 is 18. And then I add down, which is 25. And then I multiply 75. And then I add 74. And then I multiply 222. Double check me. I'm doing this in my head for those of you that are like, I can't do that. Yes, you can. Just take a second. 22.
I love Jesus.
Alex, focus. I think I have 248 as my remainder. So I could rewrite this thing as 6x cubed plus 7x squared plus 20. It was a rhetorical question. I really don't need to hear. Equals 6x squared plus 25x plus 74 plus, here's the struggle. Here's the question. First of all, did anybody get there before I did? Am I right? Yeah. Okay. If I'm right, then this is awkward. It's 248 all over x minus 3. It's my little remainder here at the end. Did this go in evenly? No. So could I, well, hold on, this doesn't equal that. Sorry, this divided by x minus 3. So did I find myself a perfect factor of my big old nasty polynomial? The answer is no. But did I divide it? Yeah, sure. Did I figure out this is really just some sort of quadratic with this little baby extra piece? Mm-hmm. Remainder, 248 over original factor x minus 3. 248 over x minus 3. So, if that's synthetic, why didn't we use that on Friday when we were doing this whole long division thing?
Because we need to learn that one too, because it only works with first degree.
X minus 5 or x minus a.
Oh, so maybe I could have? Oh, I did do it with synthetic. Yeah, I put the 0 in the box, right? I did my coefficient of, why are there zeros again?
Because you have to put
placeholders for the x squared and the x terms that weren't really there, so it's 0x squared, 0x. I brought down, I did my multiply, add, my multiply, add, my multiply, add. This one went in evenly. I wonder if that means anything. So if I was to rewrite this guy, I would get my x cubed plus 125 all over x plus 5 is equal to, what does this tell me as far as an answer? Remember what we put? He's always my constant term. What kind of term is this next guy? the variable term, and then this next guy will be the variable square term. And then if there was another one cubed, we always start with the constant, work our way out. So what does this actually mean? Can't I multiply him on the other side? Couldn't I say that what I just did with my synthetic division got me, oh, that's nice. Why is that nice? This one division, when dividing by x plus 5, since it went in evenly, guess what I just figured out of this nasty polynomial? These factors. That's a big thing in chapter 2, is taking nastier, harder, higher order polynomials and being able to factor them. Now the next thing is section 2.3. It's not about factoring nasty polynomials, it's just whether or not you can divide. It's just whether or not you can divide. Let's go back to that other example that we did on Friday. Can we go back to this example real fast? Why not just do synthetic here? I bet it'd be easier. Guess what? Can you guys look at your notes real fast? Doesn't it say we can only do synthetic with x minus a or x plus a? This guy's an x squared dude, so guess who's not able to even think about using it? Alex, do you see it? Synthetic, yes or no, for this type of problem?
No.
Because it's a square. What's a square? The dividing guy.
But that's the only first degree, right?
Synthetic division only works when dividing by first degree polynomials. Well, that's a bummer. We are going to talk some more about division today to finish up this section 2.3, but I think we have some homework to talk about, yeah?
The homework is honestly super easy.
Homework. Did we grade section 2.2? No. I didn't think so. All right, color pens out. Because we talked about the intermediate value theorem, and I didn't check homework because some of you didn't know the intermediate value theorem, and some of you used copy bonus, etc., to be able to have the weekend to catch up. So let's go grade 2.2. We'll peek at 2.3 and see if we can answer any questions about where you got stuck. Wow, something smells really good. I haven't finished my protein bar. It's still back there. No. All right, homework. Section 2.2, homework number 12. Number 8 is intermediate value. You guys remember my example to remember intermediate value? I'll stand up.
Oh, you
Does that
have
help?
to grow tall.
I had to grow tall from here to here, so what did I pass through everywhere in between?
Short. Like you.
All the short heights. Just kidding, all the shorter heights.
How tall are you?
6'2". I stopped measuring when I stopped playing basketball. Ish.
My dad.
I don't think I grew any taller. Oh, intermediate value theorem. IVT, in between heights. In between heights. We have some homework problems, but we'll get to them in a second. Number 10 and 12 and 14 is F and E and B. F and E and B. I like that, but that. Anyway, F and E and B. Hey, guess what? 10 and 12 and 14 are talking about graphs. So what should be in your homework right now? Oh.
I love that.
Number 26. Pause. I know it says to the left, to the right, rises and falls, but did you do the notation like I?
No.
I fixed it.
I did it.
Careful.
But Missy, do we have to have both the words and the notation?
No. Notation is fine. Left is x approaching negative infinity. Falls, f of x approaching negative infinity. Right, x approaches positive infinity. Rises, f of x approaches positive infinity. That one shouldn't have been too tricky. It's an odd degree polynomial positive, which means it goes like this. Right? But the next guy was an even degree polynomial. But my question is, you get that the leading coefficient was 3/4, not just 3. 3/4, and not just 3. Whenever you have something like a division by a constant, what was it? 3x to the 4th minus 2x plus 5? Oh my goodness, this is a struggle. 2x plus 5 all over 4. Question, what's another way of writing divide by 4. What's another way of writing that? You're dividing something by 4, you're multiplying it by
1/4.
1/4. So couldn't I rewrite this statement and say, hey, you're the exact same thing as 3x to the 4th minus 2x plus 5 times 1/4?
Yes.
And when I multiply any polynomial by something, doesn't there need to be distribution?
Yes.
And wouldn't that distribution carry through and say, oh, it's really 3/4 x to the 4th minus 1/2 x plus 5/4? So what's your leading coefficient? Not 3, but 3/4. Now, there was an old Algebra 1 teacher. She was Mrs. Office. Actually, she was quite young. But when I first started teaching here, and I would sit in the back and she would teach her class. We like shared her classroom. Sometimes that happens. And she would call this the heart method. Because with her Algebra 1 kiddos, or actually it was even younger than that, like her pre-algebra kiddos, there was usually only 2 things up top. And so it looked like a heart. Now the only problem is this one's a little bit weirder because there's going to be 3 things. Looks like a duck foot. But anyway,
Like a flower.
not a duck foot, like a bird.
I don't know what that's called.
Or a flower, whatever you want it to be. But there is another way of thinking about this, that each and every one divides by 4. You divide by 4, and you divide by 4, and you divide by 4. But it's really just because of distribution. Anyway, I'm pretty sure at least a couple of you got that wrong. But what is the snazzy way of writing this one?
X, which is positive infinity.
Oh, positive infinity. We're starting to the right?
I always have to write it because I'm on the right.
My document gets mad at me, sorry. Okay, I'm going to write it over here. As x approaches positive infinity. Sorry, so we're starting to the right. To the right, what happens? Leading coefficient is positive. You see it? So evens point up when they're positive, point down when they're negative. Like us when we're positive or smiling, us when we're negative. Who usually know? Oh, it's thicker when I'm in my smart notebook, but when I'm here, I don't know why it's thinner. It's just a natural thing with the program, I guess. Sorry, f of x is approaching. Isn't it rising both ways? The heights are going up and the heights are going up. To the left and to the right. Number 36 wasn't meant to be a hard one because all you had to do was factor your difference of squares set equal to 0 to get your zeros at plus or minus 9.
Wait, I have a question.
Yeah.
Since it's 81 minus x squared and not, oh, so it'd just be 9. Oh, okay.
Yeah. You can think of it
'Cause
still as an a squared minus b squared.
Like, I thought, oh, like if you flipped it, it'd be negative x squared plus 81.
At which point, Jane, that wasn't bad to think about because I know why you were doing that. But if you have that, that's not a difference of squares until, see,
Distribute the negative.
it actually ends up being the exact same thing because if I bring this in, it's going to be a negative x and a positive 9, which is what is really going on.
And the other one would be.
It'd stay the same because it's technically just multiplication. So we multiply 2 at a time and then we would multiply again.
Oh.
Do it.
Oh, I haven't gone over that one yet. When you factor, don't they both technically have understood powers of 1? Which means there is no multiple. Well, but there's still one of them. I know it's weird, it's not a multiple, but we say there's a multiplicity of 1, but there's only 1, so it's not a multiple. Stop, just say it has an odd multiplicity. You might be asked multiplicity of zeros. Because usually you're looking out for those ones that have like a squared or a cube. But remember, with multiplicity, odd crosses through and even bounces, so it's helpful to know even that the ones have odd multiplicity. Maybe it was weird, right? Multiples more than 1, multiple of 1. I know, it's fun. Turning points after vertex, and then you were graphing the check. Number 76. Number 76. Yes, you would have put f of x is approaching positive infinity as x goes to positive and negative infinity. Your zeros, did you guys pull out your GCF? And at your multiplicity of 2, did you have it bounce? Because that's the only place he could be bouncing, is at that squared factor, which is the 0. There's the bounce. And it's going to cross through, cross through. However, did you guys have it go down to negative 20-ish? Yeah. If not, you should have made a table. Now, here's the table I would have made. Here's the table I would have made. Because I would have looked at all my zeros and I would have been like, I need to figure out a point here-ish, 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 and here-ish. It's kind of preparing you for something in calculus. But I would have split up that x-axis into 4 pieces and said, I need one guy from each of you, and let's get an idea. And then I would have technically only found 2, and then I would have copied them on the other side, because the more you know math, the more shortcuts you can efficiently take. Because that even symmetry says, hey, what's on one side, just copy it on the other. But their table wasn't bad, it just wasn't quite as strategic as mine is.
No.
And I think with that we get to IDT, yeah? IDT, sorry, intermediate value theorem, IDT. He's so important he has an acronym in calculus.
Like shield.
How do you do, because it was in your homework, how do you do tables in your calculator again?
List.
Yes, if you have the numbers to type in, but we don't have a table of data, we only have a
Regression.
function, isn't it? Don't we only have a function? Yeah. Okay, so if we have a function, where do functions go in our calculators, guys? Yeah. Okay, so functions go into our y equals, and so in our y equals, how do we get a table from our y equals? Just a quick review, pre-cal graphing calculator handbook. How do we get the table if we put it here? Not the list, not the stat plot, but here. Where's the word table on your calculator? Above graph. Second, graph. Hey. But yours might not be doing that. Yours might not be doing that. So, how do we change how a graph looks? Window. How do we change how a table looks? Second window. Yeah, turn off your stat plot because you don't want that. We're not doing lists. We're doing the y equals. But you can have tables go by 1s, you can have tables go by 2s, you can have tables go by 5s, you can have tables go by all sorts of different stuff. But make sure your table is on automatic, not ask. Make sure your table is on automatic, not ask. But the long story short of homework was... Yeah. So guys, how do we find zeros in a table? What are we looking for? Where's the ding, 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 ding? I'm right here. Whenever there is a, come on, I was a baby and now I'm here. The function was negative and then it was positive. What had to happen? Yeah, I had to pass through 0 because it says where are the zeros. Go find it. Well, not with the graph first. You're supposed to find it with the numbers and try to think through IDT and say there has to be one right there. How else can there be a sign change for a continuous polynomial? If he's below and above, he has to cross to 0. There's one. Probably closer to 1. Here's one, between 6 and 7, probably a little closer to 6. And here's one, probably closer to 11. And then we could zoom in, zoom in, zoom in, zoom in. Or we could start doing things like going by 0.1s or 0.01s, but at the end of the day, you will eventually, and you could have used the 0 feature at this point, found each of the zeros and said, hey, yeah, 0 to 1-ish, closer to 1. 6 to 7-ish, closer to 6. 11 to 12-ish, barely closer to 12. But remember, we see zeros or we know there are zeros and there are sign changes by IB, intermediate value theorem, in between heights. Alright guys, questions on odds or evens of section 2.2, homework number 12. You sure? We're okay on homework number 12? Cool.
Oh, yeah.
On what?
This homework that we just graded. Any questions?
Oh no, it's light work.
I'm not sure if I did it right.
Yeah, check it out. Okay, then, while people are trying to find their questions, I'm going to pull up section 2.3 real quick. It was the one you were supposed to start over the weekend with division. Can anybody who did catch up and go ahead a bit? Because you were supposed to, I think, attach for me this morning, like at least an attempt on this, right? Was there any place it got weird? 2.3.
That was the one.
Oh, I like this one. I didn't
What?
see that on this homework. I only saw 13.
Yeah, so.
This is 13.
Oh, never mind. Okay.
Yeah, is there any place that we got stuck in 13?
Wait, what did you do?
Technically this morning.
Synthetic division.
I'll probably give Grace until tonight.
So confused. Okay.
Well, 2-2, homework 12 was due on Friday, but some of you took extra time. Okay, this didn't get weird? Alright, then let's go ahead and finish up notes then. So synthetic division, long division, what we didn't get to cover on Friday was what we can use synthetic division for. And this did get asked of you in homework a couple places.
Misty,
Yeah.
can you go over number 7?
Oh, 2-2?
Yeah, 2, 3.
Oh, 2-3. We'll grade 2-3 tomorrow because I was thinking that there would be some of you that might not have gotten it done. And I think 2-4 we technically have until Wednesday on. Number 7. Oh, Jaden, check the directions. Ready? Use long division to verify. It's weird, but what they're saying is verify. They're saying this makes that. The same way in notes we talked about how at the very beginning of this section, ready? This made that. Use long division to verify. So all you need to do is take that numerator and plop them in, put zeros for any missing terms, and then do your division. So in context of this guy, just going back to where we're going today. There we go. You would have thrown that x squared in your division box, right? You would have had that x plus 2. But you would have wanted a 0, x, and a 0.
Oh, so you want to make sure to put a plus 0 at the end.
Because that way you just have placeholders.
Okay.
So when you go to multiply, like with x, you get an x squared and you get a 2x. So you want an x term column so that you know what you're doing. You know what I mean?
So my question is, I don't know how, like in the final or y2 is, I don't know how they got 4.
Well, let's see. I'm trying to do a minus 2. Sorry. That'd be negative 2x minus 4 when you distribute.
And then the positive. Oh.
And then minus the negative.
Yeah, I did.
Okay, since we're grading this guy tomorrow, hold on, let's go peek at. We're grading 2-3 because we already graded 2-2. So I'm not going to take another grading day, especially when this next homework's due on Wednesday. But the next homework, 2-4.
It's for Wednesday?
2-4.
Let's go.
Okay. The one thing we didn't get to write down in our notes, I mean synthetic division, but some of you didn't need those steps. I still had you write them down because I was like, all right, it's still good. I still want you to write them down. But this is like the other concept that we need to get, and that has to do with what the remainder tells us. And I technically already mentioned it, but I want you to write it down. Applications in synthetic division. Here's one of them. Okay. The remainder tells us the function value, which is especially helpful if I'm looking for zeros. Which is especially helpful if I'm looking for zeros. So, guys, this example, I just thought we ran out of room, so I went ahead and took it to another page. That's all that's going on. It's the exact same example. I'm going to start doing synthetic as you guys are writing down your idea of what we're doing and why we're doing it. Looking at how synthetic can be used. So I'm going to do synthetic over here, which we already technically reviewed today. So I reviewed your box. Or we just picked up the notes. So you're okay in this one. Whenever you see this guy, the guy in front, whenever you see that guy, he's my zero or my solution. So he goes straight into the box. That guy goes straight into the box. So the very end of section 2, 3. The very end of section 2. So that one goes straight into my box. Question, yes. keep that open, because that's what this is. Because theoretically, you could just plug in, right? What Laurel's saying is like in the homework, and this is where I thought a lot of you would get stuck. I think some of you just haven't done it yet. F of 1, we just say, okay, no big deal. 2 times 1 cubed minus 7 times 1 plus 3. And then we get 2 minus 7 is negative 5 plus 3 is negative 2. Done. But they're saying there's another way, which might not seem obvious right now. Hang in there. It can make life a little easier. So to use synthetic, literally, okay, we are putting the polynomial f of in my coefficients as though he was the numerator. We're putting the function value they want plugged in into the box. So this A guy. We're putting him into the box and we're doing this synthetic division with him. So I'm bringing down, I'm multiplying, I'm bringing down, I'm multiplying. I'm bringing down, I'm multiplying. Oh, sorry, times 1. Not times 2. Check it. What's 3 minus 5? Negative 2. What ended up happening? The function value, when plugging in, ended up being the exact same thing as the remainder when doing synthetic division. That's the idea. I could just plug in, but I could also just do synthetic.
I wouldn't plug in.
Usually.
So if you just plug it in and you don't use synthetic, like on the test, you get it wrong.
Well, think of it this way. Just trust that what we're doing now is to help you with it. Because this section, like, yeah, in some ways it's like, okay, can you do the division thing? But in some ways, remember we have those really nasty polynomials that need to be factored somehow. And check it. Based on what you just saw, if doing synthetic division, if the remainder points me to the function value, then if I can get a remainder of 0, the function value is 0. And if the function value is 0, ding, 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 if I take this and if I make it into a linear pair, I just found myself a factor. This is the theorem that says, hey, if the remainder is 0, you have a factor of the polynomial that you were trying to break down. But that's for the future. Now, maybe once again, you're like, I don't get the point. Well, this whole factoring thing is going to become super important. So an application of this concept is super important. But there's also the idea that, right, an axiom? Oh, it's not too bad. It's not too bad. What if I was to give you something like, just don't worry about the directions for right now. We might get back to this one at some point, but not today. Oh, come on, it's so fun. Plug it in, plug it in. Wait. What did we just see? 4th degree, 3rd degree, 2nd degree, 1st degree. Really? Mm-hmm. But you have to, okay, yeah, but what's 4 times a half? Oh. What's 2 times a half? Oh. What's 15 times a half? Okay. What's 15 halves times a half? What's 15 fourths times a half? Okay, we have to get back to 8s, but 8 times 2 is 16. Carry the 1. That's what's 256 minus 15? Well, that's 241. got him. Oh no, I want to plug in. Alright, so I'm just saying, it's not always easier. I totally understand synthetic is not always easier for plugging in. Oh my goodness, assuming you have a calculator on this test, that's cute.
Wait, can you go back?
Ah! Section 2.4 that we're merely starting today. I need to go check Google Classroom, make sure that homework's not due tomorrow. But for us, it's due on Wednesday. Look at the board and just make a mental note. I'll make sure Google Classroom's up to date. But section 2.4 should only take us one day tomorrow because it's all about I. All about me, look, all about I. All about you, look, all about I. It's all about the imaginary number I, which comes from the square root of -1. True? And all these different pieces, like, oh wait, that's weird. Do you know that any real number can be written with an imaginary piece, and any imaginary piece can be written with a real number piece too? Huh. Complex numbers say, hey, I have real pieces and I have imaginary pieces. It starts to get a little weird. I have real pieces and I have imaginary pieces. But guys, if you check this out, this is just a foundational, hey, we're going back to the basics for a second, making sure you still remember I's. Do you see how easy some of these are going to be? What? It's adding and subtracting. Check it, it's easy. All you gotta do is say reals go with reals and imaginaries go with imaginaries, otherwise known as combined like terms, because 7 and 5 is 12, no stress. 3 plus -4 is -1, well that was easy. 3 minus 5 is -2, and 4 plus 3 is 7, well that was easy. When might it get to be a party?
Hold on.
Wait,
Don't worry, put your pencil down. You're not going to finish writing it anyway. But pause. Some of you can do homework tonight. It's not that hard, except, some of you would kill a puppy. So when we first rewrite, then after we rewrite, can we remember that there's something like, I squared. Isn't that square root of -1 squared?
Yes.
Isn't that negative? And I times an I is a real number?
No.
We're going to have to review some things. Like sometimes just because there's an I doesn't mean it stays imaginary. Oh, that's 16 and 4 is 20, everybody.
Why did squares stay there?
It doesn't anymore. Michael gives us clear about going to I's tomorrow. We're going to I's after grade 2.3. Catch up. You have a night to catch up. You can do it. If you didn't this weekend. If you did catch up, get ahead. Life's better when we're ahead. Sometimes. Bye, guys.